Hello, class 8 boys. I hope you all are safe and healthy. Okay, we were discussing factorization. So, in the previous classes, we have already watched few tutorials on factorization so as to what is the meaning of factorization and what are the uses of factorization. So now, since we have understood what is the meaning of factorization and what are the uses of factorization, now let us see how do we actually go about factorization. So there are various different methods of how do we factorize a polynomial. Okay, the first method being by taking common. Okay, so today we learn how do we factorize a polynomial by taking common. So we will discuss a few numerical questions. Solve a few questions from exercise 11.1 on page number 214. So in this exercise, all the questions are done. All the questions polynomials are factorized by taking common. Okay, so without much delay, let us see the first question. Question number 1 Roman 1 from exercise 11.1. Okay, so the first question being question number 1 Roman 1. The question says factorize the following, question numbers 1 to 8 polynomials. Okay, so question number 1 Roman 1, it reads 8x y cube plus. So how many terms do we have in this polynomial? There are two terms, the first term and the second term. Now let us see how do we factorize this polynomial. Okay, now by taking common, so what do? We just consider the first term. Okay, the numerical and the variable. So first of all, what we'll do, we'll factorize the numerical. So we'll factorize the numerical. What is the meaning of that? We will factorize 2 4s are 8, 2 2s are 4, and 2 1s are 2. So how can 8 be written as? 8 can be written as 2 into 2 into 2. Similarly, we will factorize 12 also. So how can you write 12 as? 2 6 are 12, 2 3s are 6, and 3 1s are 3. Okay. Now, question. So 8 can be written as 2 multiplied by 2 multiplied by 2 into, we have x multiplied by, what is the meaning of y cube? How many y's are there? There are 3 y's. Y into y plus. Okay, now we have 12. So 12 can be written as 2 into 2 into 3. So 2 into 2 into 3 multiplied by how many x do we have? X into how many y's do we have? Y square means y into y. Okay, so this is equal to, now since the method says by taking common, now we will see what are the common factors between both the terms. Okay, so what are the common factors? If I am to mark the common has to be present in both the terms. Okay, we have a 2 here, we have a 2 here. Okay, again we have a 2 here, again we have a 2 here. Okay, let me circle it. We have a 2 here, we have a 2, we have a 2 here, we have a 2. Okay, we have a 2 here. Do we have 2? No. We have a 3 here. Do we have 3? No. So we can't take this 2 as common, neither this 3 as common. Okay, now let us check the variable. We have a x here, we have a x, so this x and x is common. Okay, now we have a x here, but we do not have another x here, so we can't take this x as common. Okay, now let us come to y. We have this y and this y is common. We have a y here, but we do not have any more y's here. Okay, so that's it. Okay, now we have identified which are the common terms: 2 2 x y y. So these are the common terms. So what we will do in the next step, we will write the common terms first. Okay, that means 2 2s are 4 x, that means 4x, and then how many y's do we have? Y into y square. Okay, so what is common? 2 2s are 4 x y square. Let us check here. 2 2s are 4 x y square. So this term 4x and y square are present in both the terms. Okay, now we put a bracket. Now what do? We write down the remaining. We write it down. So in this first part, what is left over? 2 is left over, and what is left over? The y is left over. Then we bring down this plus sign here. Now in the second part, what is left over? The 3 is left over, and what is left over? The x is left over. That's it. So what are our factors? Our factors are 4x y square multiplied by 2y plus 3x. Okay, so this polynomial 8x y cube plus 12x square y square, the factors are 4x y square multiplied by 2y plus 3x. Okay, if you want to check whether your answer is correct or not, what you do, you simply multiply both the brackets, you will get back the question. Let us try. 4 2 is 8 x, and then y square into y will give you y cube. Then we have a plus, then 4 3 is 12, x into x will give you x square, and then y square. Okay, so if you multiply both the brackets, we get back the main question. Okay, so this is how factorization is done. Factorization of a polynomial is done by taking common. Okay, now let us take one more example. Okay, things will be more clear. Let us take one more example. Question number 2 Roman 1. Okay, the question reads as 21 py square, 21 py square minus py. Okay, 21 py square minus 56 py. Okay, so what will we do? We will factorize the numericals first. That means we'll factorize the 21 and the 56, then we will factorize the p and the y square and the p and the y. Okay, let us do it in a rough work. Okay, so let us factorize 21. So 21 can be factorized as, this will go by 3 7s are 21 and 7 1s are 7. So how can 21 be written as? 21 can be written as 3 into 7. Similarly, let us factorize 56. Okay, 56 can be written as 2 2s are 4, 2 8s are 16. Then we have 2 1s are 2, 2 4s are 8. Then we have 7 1s are 7. So how can 56 be written as? 56 can be written as 2 into 2 into 2 into 7. Okay, now let us write down the factor form. Okay, so this is equal to, so 21 can be written as 3 multiplied by 7 multiplied by p into y square can be written as y into y minus. Okay, now we come to the second part, 56. So how can 56 be written as? 2 into 2 into 2 into 7. Then we have into p into y. Okay, so we are done with the first part. Now what is our second step? In the second step, we identify the common terms. So let us mark our common terms. 3 here, no, so we can't take 3 as common. We have a 7 here, so do we have a 7 here? Yes, so our first common factor will be 7. Okay, now there is no numerical here, so we have 2 into 2 into 2, but we don't have this 2 into 2 into 2 in the first part. Okay, so we can't take any of the 2 as common because none of the 2's are present in the first part. Okay, so we are done with the numerical. Then we go for the variable. We have a p here, we have a p here, so we can easily take the p and the p as common. Okay, we have a y here, we have a y here, we can take the y and the y as common. Okay, so no more variables remaining here, and there is a y which is without a pet. Y is not present, one more y is not present in the second part. Okay, now simply what will we do? We will write down the common term. So what is the common term? 7, then p, and then y. 7py is common, 7py is common. Okay, then we give a bracket. Now we'll write down the leftover. So what is leftover? 3 and y, 3y. Okay, minus what is left over here? 2 2s are 4, 4 2s are 8, and what is left over for the variable? So none of the variable is left over. So what will be our factor? 7py, we'll put it inside a bracket, multiplied by 3y minus 8. Right, now if you want to check whether our answer is correct or not, what we'll do, you simply multiply both the brackets. So let us multiply 21 p y into y square. Then we have a minus 7 8 is 56 py, 56 py. Okay, so we have factorized our polynomial 21 py square minus 56 py as 7 py multiplied by 3y minus 8. Okay, so this would be our final answer. Okay, now let us take one more example. So I'll choose one more example, question number 3 Roman 1 from the same exercise. Okay, so let us solve question number 3 Roman 1. 3 Roman 1. Okay, now what does the question say? The question reads as 25abc square, 25abc square minus 15 a square b square c, a square b square c. We need to factorize this. 25abc square minus 15 a square b square c. Okay, so there is no change at all. What we'll do, we will factorize the numerical first. That means we'll factorize the 25. So 5 5s are 25, 5 1s are 5. So 25 can be written as 5 into 5. Similarly, we'll factorize the 15 and 5 1s are 1. Okay, so our 25 can be written as 5 multiplied by 5, and similarly our 15 can be written as 3 multiplied by 5. Okay, now we'll write down both the terms in the factor form. Okay, so this means 25 can be written as 5 multiplied by 5 into a into b into the square is just for the c. That means c will be written how many times? 2 times. Then we have a minus 15 can be written as 3 into 5. A square means a is written 2 times. We have b square means b will also be written 2 times, and then we have a c. Okay, now we will identify. Okay, so we have a 5 here and we have a 5 here. We have a 5 here, no more 5. We have a 3 here, no 3's here. So that's it. Okay, now we check for the variable. We have a here, we have a here. So a and a is common. Okay, we have a here, but there is no more a, so we can't take the other a as common. We have a b here, we have a b here. We have a b here, but we do not have any more b, so we can't take b again as common. Now next we have a c here, we have a c here. We have one more c here, but there is no more c in the second term. C, 5a b c is common. Okay, we put a bracket. Now as usual, what we'll do, we will write down the leftovers. So what is left over in the first part? 5 and c, 5 and c, then the minus sign, this minus sign comes here. What is left over in the second part? 3ab, 3ab. So this is left over. So that means what are our factors? Our factors will be 5abc within bracket, and then again 5c minus 3ab. So this will be a factor. So if we wish to check our answer, it's very simple. We'll multiply both the brackets, and this should fetch us the question back. Let us check. A B C into C, C square. So ABC square. Then we have a minus. Then 5 3 is 15. A into A square, B into B square, and then the C. So 15 A square B square C. So that will be our final answer. Okay, so this is the way we factorize a polynomial by taking common. Okay, now let us take one more example wherein we have 3 terms. Okay, wherein we have 3 terms. So I will take question number 4 Roman 1 from the same exercise 11.1. So question number 4 Roman 1 says 8x cube minus 6x square 10x. Okay, 8x cube minus 6x square plus 10x. Okay, so the process remains exactly the same. We will factorize the numericals separately first, and after factorizing the numericals, we'll write it down in the same format. Okay, so how can we write 8 as? Let us factorize. So 2 4s are 8, 2 2s are 4, and then we have 2 1s are 2. Okay, how can we factorize 6? 6 as 2 3s are 6, 3 1s are 3, and 10, 2 5s are 10, 5 1s are 5. Okay, that means 8 can be written as 2 into 2 into 2, 6 can be written as 2 into 3 and 10 can be written as 2 into 5. Okay, now let us write down it in the factor form. So 8 into 2 into 2 into, we have x cube, that means x into x minus, okay, 6 can be written as 2 into 3 into x square, means x into x. Okay, I'll write down the third term in the next line. Then we have plus 10 can be written as 2 into 5 into x. Okay, now what is our next step? We will identify the common terms, and when we identify the common terms, 6 we have 3 terms here. The common term should be in all the 3 terms. That means if 2 is common, it should be in all the 3 terms. If 3 is common, it should be in all the 3 terms. So let us identify the common terms across all the 3 terms here. Okay, so now let us identify the common terms. So we have a 2 here, we have a 2 here, we have a 2 here. So that is a common term. So we have one more 2 here, but there are no 2's now, so we can't take the next. So this also no 2's here, no 2's here. Okay, now we have a 3 here, but do we have a 3 here? No, so we can't take 3 as common. We have a 5 here, so do we have 5 here? 5 here? No, so we can't take 5 also as common. Now let us check the variable. So we have x and x, so we can take x and x common, because x is there in all the 3 terms. Okay, so we have one more x here, but we do not have any more x here, so we can't take common. Okay, x all the 3 terms, it's present in only the 2 terms, but it is missing in the third term, so we can't take x as common. Okay, so in fact if we see the third term, there is no more variable, so we can just simply stop checking the common term, because whatever variable we had, that variable is already taken as common. Okay, now what is the next step? The next step would be writing the common terms. Okay, so 2x and 2x. So what is the common term? So our common term is 2x. Okay, now we'll write down the remaining, the leftover terms here. So what is left over here? 2 2's are 4, x and x square, then we have a minus sign here. So what is left over here? 3, and what is left over here? X. What is left over here? Only 5. Okay, 2 and x have already been taken common. So what will be our factors? Our factors will be 2x multiplied by 4x square minus 3x plus 5. Okay, now let us check whether our answer is correct or not. So let us multiply both the brackets. 2 4's are 8x into x square, x cube. Okay, then a minus 2 3's are 6x into x square, plus 2 5's are 10, and then the x, so 10x. So this will be our final answer. All right. Okay, I will take one more example, and the last example for the day. Okay, let us work out one more example. I want maximum number of example, so that the concept is very clear to you. Okay, so I'll do one more question for you. So this is question number 5 Roman 1. Question number 5 Roman 1 of the same exercise. Okay, the question reads as 18p square q square, 18p square q square minus 24 pq square plus 30p square q plus 30p square q. Okay, so we need to factorize this polynomial. 18p square q square minus 24 plus 30p square q. Okay, so our process will remain the same. We'll factorize the numericals first, and then we'll factorize the variables. So let us factorize 18. Okay, so this is 2 9's are 18, 3 3's are 9, 3 1's are 3. So 18 can be written as 2 into 3 into 3. Now let us go for 24. So 2 12's are 24, 2 6's are 12, 2 3's are 6, 3 1's are 3. So 24 can be written as 2 into 2 into 2 into 3. Now the last term 30. So 2 15's are 30, 3 5's are 15, and 5 1's are 5. So 2 into 3 into 5 is equal to write down the factor terms. Okay, so 18 can be written as 2 into 3 into 3, okay, into p square can be written as p into p into q square can be written as q into q. Okay, minus, okay, 24 can be written as 2 into 2 into 2 into 3 and p into q into q. So 2 into 2 into 2 into 3 into p into q into q. Okay, now the third term I'll just write it in the second line. So plus, okay, 30 can be written as 2 into 3 into 5 into p square, means p into p into. Now since we have written it in the factor form, what will is the next step? We will identify the common terms, and the common terms should be present in all the three terms, all the three parts. Okay, so 2, 2 and 2. Okay, so we have 2 in all the three terms. So our first common factor is 2. Okay, now we have a 3 here, we have a 3 here, we have a 3 here. So 3, 3 and 3 is also our common term. Okay, now we have a 3 here. Do we have any more 3's? No, no, so we can't take this 3 as common. Okay, now we have a 2 here. Do we have any more 2? No, no, so we can't take this 2, neither this 2 as common. Okay, now we have a no, any 5 here? No, so we cannot take 5 as common. Okay, so as far as numerical is concerned, only 2 and 3 is common in all the three terms. Okay, now we go for the variable. Okay, we have a p here, we have a p here, we have a p here, so we can take the p and the p as common. Okay, we have one more p here. Do we have any more p's? No, we have a p here, but we do not have a p in the second term, so we cannot take p common in here. Okay, now we have a q here, we have a q here, we have a q here, so we can take the this is the we have a q here, we have a q here, and then we have a q here. Okay, so we have taken the q as common. Okay, we have one more q here, we don't have any more q here, so we can't take that as common. Okay, that means we are done with taking the common. Okay, so now we'll write down the common term in the next step. So this is equal to, what will be our common term? 2 3 is 6, and then pq. 2 3 is 6, pq is the common term. Okay, now let us see what is the leftover term. So we have already done with the 2, with the 3 and the p and the q. So what is left over here? 3pq. 3pq. Then we have a minus here. Okay, what is left over here? 2 2 is 4, and then we have q. Okay, then here 5, and then what is left over? P. Okay, so 6pq multiplied by 3pq minus 4q plus 5p. Okay, now let us verify whether our answer is correct or not. So for this, what we will do, let us multiply both the brackets. So 6 3 is 18, p into p square, and q into q square. So we have got the first term. Now 6 4 is 24, p and q into q square, so pq square, the last term. So this is how factorization of a polynomial is done by taking common factor. Okay, now we come to your assignment for today. So your assignment for today will be very easy. Okay, I'll give you those questions which are very similar to whatever I have discussed in this tutorial. Okay, if you have any doubt with any of the steps, you can watch the tutorial again, you can go back, watch the tutorial again, get your concept right, and then try to solve these questions. Okay, so I have done the Roman one of question numbers 1 2 3 4 and 5. So your assignment will be the Roman 2's of question number 1 2 3 4 and 5. Okay, I'll just write it down. So your assignment is from exercise 11.1, which is 214. So your question numbers will be question number 1 Roman 2, question number 2 Roman 2, question number 3 Roman 2, question number 4 Roman 2, and question number 5 Roman 2. Okay, so these numbers will be assignment from exercise 11.1, page number 214, the Roman 2s of question number 1, 2, 3, 4 and 5. Okay, so the rest question we'll discuss in our next class. I hope this tutorial will be helpful to you. If you have any doubt, you can always clarify your doubts when we are having our online classes, or send your queries to my WhatsApp number. I'll be more than happy to help you all. Okay, so bye for now. Take care.